So Dawn has been working in the grain storage with Brock Grain Systems in Indiana probably for a little while. And he's going to be talking today about something I feel like we often don't have a lot of expertise in the Northeast, especially in our area, just on conditioning, aerating, and storage of grain. And now, like I said, as the weather's starting to fluctuate, we need to be really paying attention to what's happening in those grain bins. So, Dawn, I'm going to let you take it from here.
Okay, well, thank you for inviting me. I appreciate the opportunity to talk to you folks. I was able to go out to your website and see a list of names of members and kind of what you do, and I see a lot of small operations raising wheat, rye, barley, and a lot of direct sales to the consumer with flour and a lot of bread making things. So it was interesting. Uh, it's a bit different than what we run into here in the Midwest with large grain farms with soybeans, corn, and some wheat as well. But the size of operations varies quite a bit. So, with that said, I thank you. I take Todd was the one that contacted me and wanted to know if I would do this presentation, which I'm glad to do. Um, Here at Brock, we do a lot of training, and that's one of my jobs is to help train our dealers that are throughout the world, but we have a lot of dealers here in the United States that we provide training for each year. And in fact, in just a couple of weeks, we have training sessions lined up for in several locations for our dealers to go to. So that is part of our responsibility here. And so let's see if I can share my screen and we'll get started.
We got it.
That's showing up. Okay.
Yep.
All right. Well, I didn't want to make a sales presentation today, even though I do work for Brock. Um, we understand there are other companies out there that do the same thing. We just think we're the best. So we think solid starts here. So yeah, today I want to talk a little bit about grain conditioning, the aeration part of it, and how that affects storage of your grain. Because as we all know, storage is key. If we can't store it until we need it, we probably lose it. So that's a key thing. Yeah, real quickly, Heather did a introduction already, but just real quick, my job title is product specialist. I've been here at Brock for 13 years. Um, I was born and raised on a small farm in Iowa, even though I'm currently living in central Indiana. And it was on a very small farm. And we did organic farming before that was really a thing. So we cleaned out the hog barn and the cattle barn and put all that manure out on our fields and so for fertilizer. We raised on our farm, we raised hogs, cattle, and we also had a cage layer chicken house with about 8,000 birds. So we had plenty of eggs together every day as well. Um, I consider myself a problem solver. I go all the way back to my early years of my interest in being a mechanic and being able to troubleshoot different systems, whether it's hydraulic systems, electrical, engine, whatever. And being a farm boy, my interest was in farm equipment. So that's where my first education took place was to be an ag mechanic. And I worked about 10 years at a local John Deere tractor dealer, being a John Deere tractor mechanic. I I still to this day love solving problems, coming up with solutions, and that carried me on until later after high school and after being a mechanic for 10 years. I finally had the opportunity to go to college where I wanted to study engineering, and I went to Iowa State University, graduated in 95, and at that point got a job in Indiana. And so we moved out here. And after about 12, 13 years at that job, I moved to this job here at Brock. And it was really nice to get back into farm. I don't know how I want to say it, just the farm mentality. I enjoy the farm mentality and being able to communicate with farmers and also with our dealers on a daily basis. So, a little bit of background on where I come from. So, who doesn't enjoy fresh bread? I see a lot of you guys, mill your grain to make flour for bread making. Some of you probably even do some bread making, and I might even try to get in on some of those the anatomy of wheat flour sessions that you got coming up, just to see what that's like. But quite a few years back, my wife decided to start grinding her own wheat and making homemade bread. And in fact, when our kids would have friends over to our house, they would go home and share with their family that the highlight of their visit was the homemade bread that we served at the dinner table. So at one point, my wife provided weekly bread needs for about 5 or 6 families. She would bake that much each week. And she has passed the skill that she has learned onto several of our children. And you can see here in the photo where um, one of my sons was pretty proud of making a nice batch of homemade whole wheat bread. So I should also share that I'll probably just go through my presentation here fairly um, quickly, and then at the end I'll have time to answer questions if you have questions about specific things. We can go back and we can revisit. I assume that's how you want to do it, Heather, or do you want to allow questions in the middle?
I think that's good. If people have questions, if I see something, Don, I can stop or we can take
Okay,
a break if you want. But yeah, I just keep going.
that's fine. Okay.
Oh,
So grain storage needs. When talking about grain storage, we have to differentiate between whether we're going to store it long term or short term. And the length of the safe storage is directly proportional to the moisture content of the grain. So the higher the moisture content, the shorter the time frame that we have to store it. On this little chart, we've got a grain storage life wheel. Goes down here, you can see if we have grain temperature of 40 degrees and the moisture content is 15%, we have about 500 days of storage available. We go much longer than that, it'll start deteriorating, whether it's through insects or just the breakdown because of moisture. Um, for real long-term storage, we'd like to get it down around 12%, and then you've got quite a bit of storage time available. But you can see on this wheel, if you have an 80-degree grain temperature and 15% grain, our storage time is only about a month. That's not much time. So during that month, you have to either use it or find a way to make it so that we can reduce the moisture or the temperature or both to be able to store it longer. So I think with a lot of your operations are fairly small. Um, we're not working with large grain bins, and like our large farmers in our areas around the Midwest, they have large grain bins, and they also have standalone drying operations that your grain goes through to dry. But on smaller farms and smaller operations, we generally see in bin drying systems. And the grain bins do provide really good storage because it's a way to keep it dry out of the weather. And it also, a grain bin has the aeration floors that allows the fans to, push the air in at the bottom and push it up through the grain and remove moisture, change temperature, do all those things. So then the question always is, well, okay, how many fans do I need? And how do we determine the size of the fan? When do you determine to run the fans? Do we need to add heat? And there's all kinds of factors in there. So we can talk about that a little bit. Um, just for grain, keeping things in grain conditioning, once you have the moisture content down, the general rule of thumb is 1/10 of a CFM per bushel of grain. So 1/10 of a cubic foot uh, per minute per bushel of grain. So if you have 500 bushels, a tenth of that is a tenth of a CFM is fairly small. It can be a fairly small fan. So that's how we determine fan size. We have different fan sizes that will generate different amounts of airflow. So if you're drying grain, then you need more airflow. We can go all the way up to 1/2 of a CFM per bushel to even up to 1 CFM per bushel. So all depends what you're doing, helps determine what size fan we need to put on there. So when to run the fans, we generally want to run the fans during the time of day when it's the driest and not run them while it's raining and pushing wet air into the grain. So while grain will dry as you push air across due to evaporation, it can also absorb moisture. If you push humid air, wet air across it, it can also reabsorb some moisture. And it doesn't happen as easily as taking moisture out, but it can be done. So we generally don't, if it's raining out and we run fans, we just don't get any drying operation going on. So it's really a waste of electricity to run the fan. So want to find a time when the sun's shining, it's nice and dry out, and run the fans in. And how how warm it is, how the humidity levels, those things all play a factor in how long you run the fans. Sometimes if you've just pulled grain in from the field and it's fairly high moisture, you may need to run fans for several days straight to get it dried down enough to where it will not start deteriorating with it mold or whatever is growing on it. So those are the things that kind of play into that. When we talk about aeration in a grain bin, we also need to talk about static pressure and how static pressure is related to the airflow. So the static pressure really is a measure of the resistance that air, um, the fan builds up in order to push the air through the grain. And we have many different grain types, all the way from round soybeans or edible beans to real small grains like your rye, your barley, that have really small kernels that really lay tight against each other. Those are much harder to push air through. So it takes higher static pressure to move air through those things. And I put one chart up on here that shows the static pressure for barley. And across the bottom down here is our CFM per bushel. See, we're going all the way from 1/10 up to 2.5 on this chart. And then along this left side is the grain depth. So obviously the deeper the grain is, the more static pressure it's going to take to push air up through that grain. So if we look at a depth of 30 feet, which takes a pretty tall bin now, probably not many of those out there, but and then if we want a quarter of a CFM at 30 feet, you see the static pressure in barley is 3.15. Now, these numbers in this chart are the static pressure, but as the static pressure increases, we have to remember our airflow decreases. So the harder it is to push up through, the less air that fan will push through. So it's good to know what the static pressure is in your grain so that you can determine what also helps determine what size fan you need. And you have to find a fan that will generate that much static pressure and still get the airflow that you want. So those are the things that factor into static pressures. So it's pretty standard across the industry to have different types of fans that generate different amounts of static pressure for different applications. The most common fan, especially on smaller operations, is the axial fan. And in this photo, this little fan down here is our axial fan. They could also have a heater attached to them, and they have about a medium airflow capability. A very common fan on a little bit larger bins is the low speed centrifugal, and you can see that here on the right in this photo. This has a centrifugal fan, and a centrifugal fan, the best way to describe that is more like a squirrel cage fan blade. So that's kind of the design of that wheel, and it will push air, and but it can move a lot more air. Most of the low speeds all run at a little bit lower RPM motors, but they have high airflow, but not a lot of static pressure capability. They go up to about 7 inches of static pressure, maybe. And again, there's different sizes available for different applications. We also have high-speed centrifugal fans, so they look very similar, but the high speed is able to generate much higher static pressure. So you would use a high-speed fan on taller grain bins where you have to generate higher static pressure to get air up through. The airflow is lower, but so sometimes it means you have to have multiple fans to get the amount of air that you need. Then the fourth one is an inline centrifugal. So it looks a lot like an axial fan, but it does actually have a centrifugal wheel inside of here and run much quieter than the vane axial fans that are probably most common seeing. So there's different applications for the different types. Um, I would assume that up in your area, the most common type is either going to be the vane axial or the inline centrifugal. So then we have to talk about a couple different types of aeration. There's a positive system and a negative pressure system. Excuse me. The there's advantages and disadvantages to the two. So I'll just point out a few of those things here. Um, on a positive aeration system, which is what is most common. I'll just put it that way. Fans are at the bottom of the bin, sitting on the ground there, and they push air under into the bin under an aeration floor, and then that air can move up through the grain and exit out the roof vents at the top of the bin. So we're pushing air in the bottom, exits out the top. That's a positive aeration system. The advantages of that are the fans are down on the ground, they're easy to maintain, and it also allows heaters to be added to those fans that are setting down on the ground. And then heaters always require extra operation time. And so you definitely want to have those down on the ground where you can get to those easily as well. So again, that's the most common system, is pushing air up from the bottom and exiting out the top. On a negative aeration system, of course, it works just the opposite. We want to pull air out the bottom and push it in at the top. So we can do that two ways. We can either install fans up near the eave of the bin, push it in there and exit it out the bottom through vents, or we can set the fans at the ground and duct air up the side of the bin, or we can actually reverse the fans and connect the inlet or suction side of the fan to the bottom of the grain bin and pull air out. That will draw fresh air in at the top. So some of the advantages of having a negative system is you can monitor the condition of the grain easier with a negative system, because grain that starts to deteriorate will start to have an odor to it. You can smell the deterioration. So if you're exiting air out the bottom, you're there where you can smell it and you can make changes, do whatever you need to do to change that. If it's exiting out the top, you can't really do that. So that's an advantage of a negative system. The other advantage of a negative air system is sometimes you have some grain in your bin, and as you push air up from the bottom, by the time that air gets up to the top of the grain, it's warm. It's already full of moisture from the grain below, and so you may have some things. The grain near the top of the bin of the pile may not be getting dry enough soon enough, and it may start deteriorating. You may have mold start to grow there, things like that. So by reversing the airflow and drawing air in at the top, you can get that fresh, dry air hitting that grain at the top of the bin and start and be able to control and dry that down before it starts to deteriorate on you. So that's another thing that can be done with negative air pressure system. Obviously, the positive, the positive system is the most common. So we can also add some heat to the airflow, depending on your needs and how much moisture is in the grain, how quickly you need to get it down to a moisture level that is safe to store. If it's real cold out, we don't need to dry it as quickly. But if your falls are anything like ours here, you can still get 70, 80-degree weather during harvest. And if you remember back on that storage wheel, grain that's at that temperature really doesn't have much storage time. So we want to get it dried down. And so we can add heaters to our fans. We have upstream and downstream heaters. A downstream heater just means the heater is installed between the fan and the grain bin. So the air flows from the fan through the heater into the grain. Upstream heater is installed on the inlet side of a fan. So the fan draws air through the heater and then blows that air into the grain bin. Upstream is more applicable on centrifugal fans than it is on a axial fan. So the most common operation on a bin that has axial fans is a downstream operation where you would have a heater between the fan and the grain bin. Then we can have low temp heaters or high temperature heaters. We generally recommend low temp in places where there's storage of seed that will be planted, just to preserve the germination properties. If we get it too hot, it probably won't germinate when you go to plant it. And also any grains that break easily, that tend to crack, we want to use low temp heat. And so there's some grains that are more durable. They can tolerate the high temp. Obviously, with low temp, the drying time and process takes longer than if you have high heat. So it kind of depends on what you're drying, how fast you have to dry it. Depends on whether you're going to be using a low temp heat or high temp. Then we have natural air drying. A lot of guys like to use this. There's definitely some advantages to using natural air drying, but you have to have the right um, conditions going on in order to do that. Natural air drying requires a lot more airflow, and because it takes more air to get across that grain and absorb moisture. But the advantages are that it does lower your cost. You don't have fuel cost for the heater. There's less grain shrinkage. If you're drying grain that you're taking to market, the more shrinkage is, the less bushels you have. So, and then also kernel breakage. That's another advantage of air drying. We could reduce the kernel breakage. And if you have too much of that, obviously, if you take it into market, they start docking you on those things. So, and then the disadvantages are slower drying times. You may just not be able to dry fast enough to get that grain down to a safe storage level. So that's running through it fairly quickly. The basics of aeration. Um, I would be open to some questions if any of you have questions that maybe I didn't answer or go back and expand a little bit more on.
Great. Thanks, Don. There are a couple of questions coming in, so everybody can get your questions in the chat. That'd be great. So, Aaron, I don't know if you want to unmute. That's fine with me if folks want to ask their questions directly to Don.
I have just a couple questions. When you use a manometer to measure the air static pressure, does it matter where you put it on the base of the bin? Does it have to be next to the fan or on the opposite side of the fan? Or
Good question. Manometer is used to measure the static pressure. And we know that static pressure affects the amount of airflow. So I like to check it a couple places, to be honest. I like to, you can go any place in the plenum area of the bin and check it there. But if you have high static pressure in the transition, the ductwork that goes from the fan to the bin, that will affect your airflow. So I generally like to check it two places. One is anywhere around the bin, and then I also want to check it in the transition or the ductwork between the fan and the bin. And because that really, the one there in the transition will really determine your airflow, your true airflow from the fan. It's also good, really good to know if that transition is really contributing much to the static pressure. If there are guidelines for the design of those transitions, you don't want real sharp angles. You don't want to create turbulence in the air. That will raise the static pressure and decrease the airflow. So obviously when your motor on your fan is running, it's consuming electricity. It will consume the same electricity whether you have almost no static pressure or if you have high static pressure. And then if you have high static pressure, you're getting a lot less airflow, so your fan has to run a lot longer. So that's where I would check them. I would check it in the transition and then at the bottom of the bin as well.
another question I have is, if I don't have a heater on my fan, can I just stick a salamander in front of it? If, 1 year things are right and I just want to add a little heat.
Well, yes, you can. That little bit of heat will be pulled right in there, and that won't really affect the airflow. If you had high temperature heat going in to the inlet of the fan, it would affect airflow, but small salamander in front of there would not change that any. And yeah, it's a little bit, you gain some dry air going in there. That's what you do when you add heat is you dry the air by adding the heat. So
Okay. My last question is if you have an opinion on bin stirrers.
well, there are yes, there's definite advantages to bin stirrers, and it does help allow the air to flow up through the grain a little bit better by having a stirrator in there. Um, in the programs that we use to help us determine airflow, we do allow a factor 4 stirrators so that it does actually give us a little bit higher airflow if we have stirrators. They help um, keep the grain mixed up a little bit, allow it to dry a little faster. Um, so yes, there's good about them. There's also a lot of maintenance on them from what we understand. So, but yeah.
Thank you.
Great. Thanks, Aaron.
Mhm.
Richard, you had a question about weevils. Do you want to ask that?
I was wondering if you've ever heard any of those grain weevil. It's like a little robot that crawls around on the top of the grain in the bin.
You were actually talking about grain weevils, Richard. So
Yes,
good
grain
thing
weevil.
you
Yes,
clarified.
it's no. This is the name of this thing is a grain weevil, and it is like one of those battery powered robots you would have in your house, a vacuum cleaner. Only instead of wheels, it's got little wings on it, and it actually crawls around on the top of the grain, and keeps the top surface stirred up. Have you ever heard anything about those, or?
I have heard of them. I've not heard of anyone or seen anyone using them. My first thought would be stirring the grain a little bit at the top. I don't really see much advantage of doing that.
Okay.
I'm not sure without
I
reading
think
some
their
more
idea
about
was
them.
that it would help break up that moisture cap that can build up at the top. I think that was the idea of making it.
You can have situations where if you're drying, and you had high moisture grain, you get a lot of condensation up at the top along the bottom of the roof panels that can drip down on the grain and eventually form a crust on top.
Oh, okay.
And that crust would minimize the amount of airflow through the grain then. It's just like a block. So maybe that weevil is designed to go up there and break up that crust so that the airflow can get back up through there again. I'm not exactly sure, but that might be
Okay.
the application thereafter.
Great. Thank you.
So the idea would be to avoid that condensation, so you don't have that moisture dripping down on the grain, and that's all controlled by airflow. You know, so if you got a lot of moisture condensation accumulating up there, then you probably don't have enough airflow.
Great. Todd, you've got a good line of questions. We'll let you go next. That's
Thank
great.
you. So I'm talking to the man who saved our crop 3 years ago when it was too wet by reversing the fan. Thank you, Don.
You're welcome.
I will always appreciate that. Could you talk a little bit about sending cold air into our Brock silo at the winter when the air is cold? Is that going to help with insect control and or just to ensure grain stability? We did turn on the fan 3 winters ago in the middle of the winter for the first time when we found out that the relative humidity was dry enough to do that, and that brought our winter rye down to 12% moisture finally.
Yeah, obviously, think back that storage wheel that I had on one of my first slides.
Yeah,
Grain temperature is critical. So in the wintertime, if we can pull grain in there, cold air in that bin and cool that grain down, we increase our storage time. The air is usually much drier in the wintertime also. So by pulling that cool, dry air in, we can finish drying if we don't already have that. I don't know if freezing those grains would damage those as far as germination, things like that, or not. But around here, when we have corn and corn storage especially, guys like to get it down a little bit below freezing. Let that corn be as cold as it can be, and just so it doesn't deteriorate. It kills off the insects. It stops any deterioration from moisture. So it has a number of advantages like that.
Okay.
The trick with that is if you get it really cold, is to allow it to warm up slowly in the spring. If you warm up too fast, you're going to end up with a lot of condensation up in that roof again, and it'll drip down on the grain and form a crust up there that can be hard to get out when you go to unload the bin then.
Okay. Okay, thank you. We've always been searching for a tool to measure relative humidity. Is there a handy tool that you can advise farmers by? You know, what we've been getting from the hardware store is not really accurate enough, and I want to take it up some notches in terms of quality. It's so important.
You're talking about relative humidity in the air?
Yes, to know when to turn our fan off and on. We follow the equilibrium chart, and that's question number 3, but we can only find them for wheat and barley and other crops. I have never seen an equilibrium chart or the X and Y coordinates for relative humidity and temperature.
Yeah, so your first question, I don't have any sources for instruments to measure relative humidity either. So I'm not much help there.
Okay.
When it comes to equilibrium moisture content, the universities generate those generally. And we know there's a lot of charts out there for the grains like corn, soybeans, wheat. All those are readily available, but sometimes those smaller grains are not. And just to expand a little bit, Todd, on so the others know what we're talking about with equilibrium moisture content, is grain will, how do I want to say this? There's the humidity level. If your humidity in your air is low, then it will absorb moisture coming off of the grain, and you can carry that moisture out with that air. There is a point, and that's what the chart is used for, is there's an equilibrium point where you could run a fan for 20 days if the humidity level and the temperature was at a certain point. You wouldn't change the moisture content of that grain at all. You could run it if it was at the correct temperature and humidity levels. So then you start to change the temperature or the humidity. Now that grain will either absorb or dissipate moisture. So if you're at that, if your temperature and humidity levels are at that point where your grain won't dry any, then there's no point in really running the fans during that time. So that's why, Todd, you're talking about using that to determine when to run your fans and when not to.
Yeah.
There are some moisture sensors that can be purchased that will actually help control and turn your fan on and off automatically based on humidity level. So you could dial it in so that your fan would only run if the humidity level is lower than your set point or the temperature is lower than your set point. There are some companies out there that make devices like that as well.
Okay. Okay. For the last 6 years, we've been using the equilibrium charts, often from South Dakota, for many other grains besides winter rye that we grow on our farm. So I still have to wing it. Which chart do you think is the most comparable to rye if I cannot find one for winter rye? Should I be picking barley or wheat or hard winter wheat? Do you have any sense about that, Don?
Todd, I don't really have a sense on that. I don't know
Okay.
those grains well enough, to be honest with
Okay.
you. So,
No problem. Okay, and lastly, at the beginning of this, I sense there's some challenge to grain in a silo and the change of seasons. Is that anything I should learn more about? You know, I'm sitting in a barn right now and looking out the window and there's just rain, puddles of water everywhere. It's a wet day in late March. Should I be more on top of things now than I was a month ago or back in September or October?
well, like I said, as it starts to warm up again, if you had your grain
Okay,
dropping down to fairly cold, you can use your fans to gradually warm that grain up to eliminate a lot of condensation going on. If you don't run fans, there are convection currents that go through the grain just due to the heat that's in the grain or heat that's outside. And so there, if you have too much temperature differential between the air outside and the grain inside the bin, you'll get condensation. So it's just a good idea to run the fan a little bit as your season changes to as it warms up now to just gradually help that grain come up to temperature and kind of keep it close to your outside temperature.
okay.
So
Thank you very much.
you're welcome.
Great, thanks, Don. We have a few more minutes, and Andy, I see you're on. You have a question. Do you want to ask? Or maybe you're gone. Oh, no.
No, no, I'm here.
Yeah.
Hi, have you heard of perforated towers inside of a grain bin?
Yes, there are perforated tubes that can be put in a grain bin that can assist in getting air up through, especially if you have a taller silo that and your fan has problems pushing the air up through. You can get perforated tubes that go in there. Those will interfere, however, depending on your unload system. Most farmers that have very big storage bins have an unload system, maybe that has a sweep auger on it that goes around to pull the grain to the center once it stops free flowing out. So if you had tubes in there, you wouldn't be able to use a sweep to clean that out. So if it's a small bin, that's not a big deal. You just get in with a shovel, but that'd be the downside of that. But yes, there are some available to do that. And again,
Great.
you would use those when you have a taller bin that you have trouble getting air up through.
Okay, thanks.
Any other questions for Don? We're kind of approaching 12:30. That's usually when we try to wrap things up by, unless there's lots and lots of questions. Anyone else? Any specific questions about crops, specific crops? The different growers on here. Not everybody's growing small grains.
This
Aaron?
is, this is Aaron
Yeah.
again. So, storing and drying and handling different grains vary. So is there basically a general difference between oil seeds and starchy type seeds? I hear farmers say that, storing soybeans is a different ball game than storing corn.
It's a little different, but I don't know. I've never heard anybody really refer to the differences between, soybean being an oil-based seed and a corn. I know we have to use lower temperature to dry soybeans, but actually, I don't know if that pertains to all oil-based seeds like that or not. It's a good question.
Yeah.
Mm.
Okay. Well, I thought I'd try.
Yeah, I don't know.
Yeah, I feel like Aaron, I've heard the same thing, but more related to like sunflowers as oil seeds, or even hemp grain. And I've heard of fire, I remember when we were working on sunflowers, people had mentioned don't put heat on it. It may catch on fire. They were really referring, I think, to I don't know, the hairs on the sunflower or something, just on the seed. It's got a lot of, they're not really hairs, but they're easy to catch on fire. And then it being an oil seed, it's quite, quite a boom. So you haven't heard anything there, Don?
Not really. I just recently worked with a farmer in Illinois that dries pumpkin seeds for snacks,
Yeah.
and they actually even apply some fast heat to them to puff them up a little bit, and then
Interesting.
they apply seasonings to them and things like that. So, but they have to be very careful on applying heat because they will start burning rather easily. But I don't know if a pumpkin seed is an oil-based oil seed or not.
It is, actually.
Okay,
Yeah.
yeah. Um,
Huh.
so
Interesting.
it'd be similar to sunflower, I think. They had a special setup to dry them though. It was not in a bin. It was different setup where they could stir them and do all those things to them. So
Interesting. All right. I have one last question. We have 1 minute left, Don. What do you know about drying popcorn? Now,
well,
Indiana grows popcorn, don't they?
yes, we do.
Yeah.
We have. I've been to places where they have bins, 15, 20 bins of popcorn. So owned by, what's one of the name of the popular popcorn?
Vol
Yeah.
Redenbacher.
Wasn't for Orville.
Oh.
Jolly.
Yeah, there. Catherine's even chiming in.
I
Dizzy
see
Pop.
their,
I'm a popcorn lover.
I see it on their microwave popcorn all the time. But anyway, there's charts out there for popcorn. It takes a lot of air, usually not applying any heat, but just natural air drying. So they're usually trying to get somewhere 1.5 to 2 CFM per bushel to dry that and keep it conditioned. So the grain bins that I've seen with popcorn in them have many fans pushing a lot of air. And it does build up quite a bit of static pressure, so you have to have high speed fans generally.
Interesting.
So yeah.
All right. Well, thank you so much, Don. It was great to hear from you. And I don't know if we have your contact information, if you know, care if people,
I could provide that for you.
okay, we can
And
send that out to our group. That would
Yeah.
be really great, just in case people have follow-up questions or need assistance with drawing
Sure.
setups. Be super.
sure, if I can help, I'm happy to do that. So
Great. All right. Well, thanks to Dawn and thanks everybody for coming today. And hopefully we'll see you next Wednesday for our webinar on dry beans. Otherwise, have a wonderful day. Thank you.
okay, you're welcome. Thank you.
Thank you.
Thank you, Don.
You're welcome.